This video is presented to you by www.testprepadda.com. Testprepadda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Dear students, you can see on your screen mathematics for physics. So here we will learn mathematics that will be used in physics. You may question that why do we require mathematics for physics? So let me tell you that a basic knowledge of maths is required. We need to have a basic knowledge of maths if we want to understand or apply physical principles. You can say this maths as the language of physics. In this chapter, we will learn about vectors. Before I start vectors, you answer that what is 2 plus 2? You may think that what a silly question is this? You will say 4. Definitely it is 4. But have you ever thought of getting 2 by adding 2 with 2? Have you ever thought of getting 2 by adding 2 with 2? You will say never. In this chapter, we will learn this. Now, to understand vectors, think about two categories of physical quantities. Category 1. In the category 1, I am going to take mass, volume, density, time, temperature. In the category 2, I am going to take physical quantities such as acceleration, force, velocity, displacement. Now, first you think about the physical quantities of category 1. For example, mass. If I ask Raju that what is your weight? He may say 50 kilogram. So 50 kilogram is the weight of Raju. Do I need any kind of direction for this mass or weight? No, 50 kg is just 50 kg. But if you think about acceleration, for example, if I am driving my car, and I apply acceleration, It means the speed of my car will increase, and that is in the forward direction. I have applied acceleration for the forward direction. Now if I apply brake, if you apply brake means deceleration, or better I say acceleration in the reverse direction. That means the speed of my car will decrease. So to tell about the acceleration, I need to tell the numerical value. For example, I am applying acceleration of 5 meter per second square, and as well as I need to tell direction, but that is not in the case of mass. Second, if I ask the weight of Chintu, Chintu may say that his weight is 45 kgs. What will be the total? Total will be 50 plus 45, and that comes 95 kilograms. So here I am using ordinary rules of algebra for the addition. But in case of acceleration, if I say I have applied acceleration in the forward direction 5 meter per second square, and acceleration in the backward direction 5 meter per second square. What will be the resultant? The resultant in this case will be 0, and that you can easily explain because I have applied acceleration and deceleration of the same magnitude, same numerical value, same value. So here we cannot use ordinary rules of algebra. Now, physical quantities of first category, I can say, are described completely by numerical value. These quantities do not require direction. These physical quantities we say as scalar, where I can describe physical quantity with the numerical value only. And here, ordinary rules of algebra, for the addition purpose, ordinary rules of algebra can be used. But for the physical quantities of category 2, we require numerical value as well as direction. These physical quantities we call as vectors. Dear students, please note that for vectors, we cannot use ordinary rules of algebra for addition. Here we use law of parallelogram of addition. This we will discuss later on. But the conclusion part here is a vector A vector has magnitude, has direction, and follows the law of parallelogram of addition. It is very, very important because there are few other physical quantities. Uh, for example, current. We may get confused that current, we may relate current as a vector. But if I talk about current, if I say current is flowing in this wire, 5 ampere current, 5 ampere current. So 5 is the magnitude. Now since it is flowing in this wire, so obviously there will be a direction. So this current has magnitude as well as direction. So we may get confused that this current is a vector, but actually it is not a vector because it does not follow law of parallelogram of addition. In case of current, if it is 5 ampere on this wire and 3 ampere in this wire, the resultant will be 8 ampere. It does not follow the law of parallelogram of addition, so current will not be considered as vector. Now, how do we represent a vector? Dear student, please note that every vector has three characteristics. Every vector has three characteristics. Number one, magnitude, or I say length. Number two, line of support. Line of support. Number three, direction or sense. You are aware of magnitude, you are aware of direction. Now I'll talk about line of support. First of all, what is a line? You may say that a line is a collection of collinear points. Line I can draw, it's a collection of collinear points. Infinite number of points are there. Now, this line does not have ends. This line does not have any length, so magnitude is not there. This line does not have any direction, so both this line does not have magnitude, this line does not have direction. Now if I take a segment on this line, if I take a segment on this line, let me select another pen. I am taking here segment, this, let us say A, B. Now you can say this as line segment, so length is there. Length is there means magnitude is there, but the direction is not there. It can be any way. So direction is not here. Now if I take the line and here line segment, and if I this as the line segment AB, and now I am giving a direction to this line segment. So this time now you can say this line segment has magnitude, this has direction also. So we say this as vector, and we represent this vector as EB, and above this an arrow, that is the arrowhead is right hand side, the right hand side. Many times vectors are also represented just by bold face letters. So I can write this as EB, bold letters. So the representation is also clear. The length or magnitude of a vector is written as modulus AB. Modulus, or simply you can say this as mod, which we can also write as AB without arrow, but this time do not write in bold letters. So this is actually the magnitude of vector AB. So here we talked about three characteristics of the vector, that is magnitude, direction, and the line of support. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.